At the back of it, he had a big garden shed, which might seem like the size of my house. And in it, he had 2 lead balls, like this, suspended from the ceiling. Only this is not to scale. This is, I mean, lead balls. Now, the real problem is that he wanted to measure the attraction between 2 objects due to gravity. In other words, there's a gravitational attraction between you and me, or between me and this lead ball. So he had to be a long way away to look at the experiment, otherwise he'd interfere with it. So he had an aperture, a place where he could look through, and he put a telescope out there, and he stood outside in all weathers, and he was in his 60s doing this, staring through the window to take his measurements over a year. There's another set of lead balls inside there. This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated. And then right in the middle there's a bit of glass, there's a mirror which should be suspended from a torsion wire. So you'd set it up like this in his shed, and you put it like that, and this lead ball would attract that lead ball, and this lead ball would attract this one. And so it would be pushed a little bit this way and twist the wire, and that would be pushed a little bit that way, and the wire would twist, and as the wire twists, the mirror, which is dangling in there, would twist a little bit, and light which comes in would be reflected off at a slightly different angle, and all he had to do was measure the angle. He then had to move it the other way round. Oh, he didn't move this bit, he moved the lead balls round so that you had an equal and opposite effect on the other side. So instead of you'd have that configuration. He had this is a very complicated technical thing for the time. 18th century we're talking about, and he put that way round, and then it was pushed the other way, and you could then see the displacement. Moreover, you could measure the period of oscillation of this, and from that get all the properties of the wire, the torsional constant. And that enabled him to measure big G, the gravitational constant, to an accuracy of 1%, and nobody improved on that for 100 years. He didn't describe it as that. He described it as though he was weighing the Earth. He was calculating the mass of the Earth, so that when you're attracted to the Earth through gravity, it's the product of the mass of the Earth, this big gravitational constant, divided by r squared, the radius of the Earth squared, which we normally know as acceleration due to gravity. And that quantity is essentially big G, and he measured it, and nobody could do a clever experiment. So he's a father of physics, experimental physics, some of the ideas of theoretical physics, and a lot of chemistry.
So
isn't it funny that the only experimental evidence that we have for gravity goes back hundreds of years to Cavendish, and then there's a lapse in any sort of experimental evidence for gravity up until the year 2015, when LIGO discovers 1.2 billion year old evidence for gravity waves. I mean, it is a bit convenient that gravity was very much in the realm of theory right up until the point when flat earthers were pointing this out, and then magically and mystically we get evidence for gravity.
So isn't it just a bit convenient that gravity remained in the realm of theory, gravitational waves more specifically, but gravity in general, remained in the realm of theory till just after flat earthers started pointing this out to the population, and in fact debunking the heliocentric model and making the rather obvious and true assertion that gravity doesn't exist. It's again, a figment of the imagination. It is a phantom of the globe Earth theory. And again, this is not to argue what goes up must come down. Yes, even flat earthers agree that if you drop a brick on your foot, it's going to hurt. Or if I jump off a window, jump out of a window, I'm going to fall and hit the ground. Yes, that is all true indeed. Again, the point that is in contention here, the thing that we're arguing here, is what exactly causes it, right? So with all that caveat out of the way, it wasn't until very, very recently, and again, this is right after flat Earth proponents start pointing all this stuff out, these problems with the ball Earth in general, that's when science, or science with a capital S, scientism, steps forward with their so-called proof of gravity or gravity waves. So I'm going to read a couple of articles, or read through a couple of articles. I don't know if I'll read through the whole thing, but I may, because there's just a lot of gold in here, and I will interject as necessary. The first article is going to be from spaceplace.nasa.gov, and the second article is going to be from www.newsscientist.com. I will put links in the description box for you guys below in case you're interested in reading. Okay, so this first one here, I really kind of enjoyed reading this, so I may read the whole thing. It is a bit lengthy, but again, this is not published by flat earthers, not in the slightest. This is written by standard globe Earth believing bona fide scientists who are pointing out that LIGO lies. Well, I don't know if I'd go so far as to say that, but LIGO definitely stretches the truth, living up to their name, and honestly, I couldn't have said a lot of this stuff better myself, no way, and so I'll just let the scientists say it. Again, these are their own guys. One of the boys is writing this stuff against LIGO. So let's go ahead to it. And again, this is newsscientist.com. The article's called Exclusive: Grave Doubts Over LIGO's Discovery of Gravitational Waves. And this is a bit dated. Don't you just love how they never date an article? Here we go. Yes, they do. Okay, so October 31st, 2018. So this was, wow, Halloween, All Hallows Eve. Okay, so, again, this article's written by Michael Brooks, October 31st, 2018, at newscientist.com. All right, so the news, we had finally found ripples in space-time reverberated around the world in 2015. Now it seems they might have been an illusion. Let me just stop it right here. So you mean to tell me that the real computer simulations might have been an illusion?
By the way, this is not a Hollywood production that I'm going to show you. It is actually a real computer simulation.
You mean to tell me that the ripples in space-time might not have been detected? Because again, you guys, I mean, come on, space-time. I mean, think about that just for a second. Space-time. You've got physical, tangible, measurable space. This is a thing. This is an object. Objects exist in space. It is of a physical nature. It is of substance. It damn sure ain't ethereal. This is corporeal. This is tangible space and meshed together with time, a construct of the mind in order to organize events along a chain. So this would be like verb stuff, right? Okay, so time is definitely not a tangible thing that you can touch and pick up. There is no weight of time. It is certainly altogether different than space, right? So right out the gate here, you guys, I'm terribly sorry that just because Einstein thunk of a thing called space-time doesn't mean that it is a thing, okay? We certainly do have space, and we certainly do have time, but I'm sorry, kids, space-time just ain't a thing, okay? The idea of space-time is tantamount to claiming that you can weigh the dream of a fart, right? So how much does the dream of your fart weigh? And scientists at NASA would have an exact answer for that. Okay, that's about the same realm that space-time is in as far as I'm concerned. So I got off a bit into the weeds right here in the first sentence of this article, so I'll just take it from the top again, because it is just a lovely, lovely opening to an article coming from mainstream scientists who just love NASA. They wear NASA underwear. They've got NASA baseball caps. These guys love them some NASA and some space time, okay? The news we had finally found ripples in space time reverberated around the world in 2015. Now, it seems they might have been an illusion. Okay. There was never much doubt that we would observe gravitational waves sooner or later. This rhythmic squeezing and stretching of space and time is a natural consequence of one of science's most well-established theories, Einstein's general relativity. So, when we built a machine capable of observing the waves, it seemed that it would only be a matter of time before a detection. And, I would have to sort of agree with this sentiment. I mean, assuming the ball Earth sort of universe where we have balls spinning around in space, somehow magically held together in their orbits by some invisible force, a gravité, naivete, I would say, eventually you'd think you would be able to find some experimental evidence for it. So I agree with that first paragraph. I mean, eventually you should find evidence for such a thing, right? It should be, well, frankly, everywhere. Much like magnetism, you can find experimental and tangible evidence for magnetism, even though you can't see magnetism, right? We do know that it is there, and there are different ways that you can prove it is a thing in reality, right? Not so much for gravity, but anyway, continuing on with the article. In point of fact, it took 2 days. The Laser Interferometer Gravitational Wave Observatory collaboration, better known as LIGO. I gotta tell you, the guy that writes the acronyms for NASA definitely earned his $100 million on that one, I gotta tell you. Right? I mean, it costs a lot of money to come up with these acronyms, and it's hard to be NASA, so that guy deserves a bonus. Okay? The Gravitational Wave Observatory collaboration, better known as LIGO, switched on its upgraded detectors on 12 September 2015. Within 48 hours, it had made its first detection. It took a few months before the researchers were confident enough in the signal to announce a discovery. Headlines round the world soon heralded one of the greatest scientific breakthroughs of the past century. In 2017, a Nobel Prize followed, and 5 other waves have since been spotted. Or have they? That's the question asked by a group of physicists who do not have their heads shoved entirely up their bungholes. No, I made that part up. A group of physicists who have done their own analysis of the data. Quoting these physicists, quote, "We believe that LIGO has failed to make a convincing case for the detection of any gravitational wave event," end quote, said Andrew Jackson, the group's spokesperson. According to them, the breakthrough was nothing of the sort. It was all an illusion. The big news of that first sighting broke on 11 February 2016. In a press conference, senior members of the collaboration announced that their detectors had picked up the signature of gravitational waves emitted as a pair of distant black holes spun into one another. Wow. Distant black holes, and mind you, black holes are also very much in the realm of theory, certainly do not exist in reality, knowing that flat Earth is the truth, but even from the standard infinite space paradigm, black holes are very much in the realm of theory. Nobody has ever gone up to a black hole and verified that it is there. right? So two hypothetical things spun around and hit each other. I mean, this is really about as tangible as the dream of a fart. I mean, it is almost a perfect analogy there. So, spun into one another. The misgivings of Jackson's group. The misgivings of Jackson's group, based on the Niels Bohr Institute in Copenhagen, Denmark, began with this press conference. The researchers were surprised at the confident language with which the discovery was proclaimed and described to inspect things more closely. With which the discovery was proclaimed and decided to inspect things more closely. So perhaps these guys were actually doing some science over there. They weren't just jumping on bandwagons and agreeing with things that the guy said who's head of the multi-billion-dollar lie factory. I gotta tell you, it is very easy to just jump on the bandwagon with the guy heading up the multi-billion-dollar lie factory, because I'll tell you what, scientists love to get paid, and so, if the billion-dollar lie factory is saying something and the guy who's heading it is saying something, why would you argue with him? Why would you question him? Why would you scientists? I mean, come on, what are you guys thinking out there sciencing like some scientists? Yeah, right. So anyway, and I would say that really is the big news here, is that scientists were actually sciencing. But anyway, I digress. We'll get back into the article. So these dreams of the farts spun into one another. The misgivings of Jackson's group, based on the Niels Bohr Institute in Copenhagen, Denmark, began with this press conference. The researchers were surprised at the confident language with which the discovery was proclaimed, and decided to inspect things more closely. Well, sorry, I read that double. What the hey? Their claims are not vexatious. And I went ahead and looked up vexatious because that is not a word I'm familiar with. So you learn something new every day. For your information, all y'all non-phonics elite out there, vexatious means causing or tending to cause annoyance, frustration, or worry. Right. Well, I guess that makes sense. I know what vex means, right? So their claims are not vexatious, nor do they come from ill-informed troublemakers. Although the researchers don't work on gravitational waves, they have expertise in signal analysis and experience in working with large data sets, such as the cosmic microwave background radiation, the afterglow of the Big Bang theory that is spread in a fine pattern across the sky. Okay.